This is the model BBD 2 Venturi carburetor. It's used on AMC and Jeep six-cylinder engines. In this release, we will examine how the BBD 2 Venturi carburetor operates, some drivability symptoms that relate to the carburetor, and just how to go about making proper service adjustments. While viewing this film, make it a point to remember that drivability symptoms can involve more than the carburetor itself. The entire fuel system, the ignition system, emission devices, and the condition of the engine have an effect on drivability. Your technical service manual and film reference book will help you isolate and identify service needs. Now, let's get into BBD 2 Venturi carburetor operation, starting with the fuel metering systems. The BBD carburetor essentially has the same circuits used in other carburetors. These are the float circuit, the idle low-speed circuit, main metering and power enrichment, accelerator, and choke. This graph describes engine fuel requirements, and we'll use it to show how each fuel metering circuit and system comes into play. Starting with the float or fuel inlet system, you'll see that the float is used to constantly supply fuel to all the fuel metering systems. The choke is used to temporarily enrich the fuel-air mixture, which aids in starting and running a cold engine. On this portion of the graph, we see that the idle or low-speed circuit provides the proper fuel mixture for idle and low-speed engine operation. A rich mixture is used for smooth operation and prevents random misfire caused by a too lean mixture. And this is how the idle and low-speed circuit operates. Fuel flows through the main metering jets into the main wells. The idle pickup tube meters the fuel, which is mixed with air entering through the idle air bleeds. At curb idle, the fuel-air mixture flows down the idle channel and is mixed with more air, which entered the idle channel through the transfer slot. The idle mixture adjustment screw controls the volume of the fuel-air mixture that is discharged below the throttle valve. During low-speed operation, the throttle valve moves, exposing the transfer slot, and fuel begins to flow through the transfer slot as well as the idle port. As the throttle valves are opened further and engine speed increases, the airflow through the carburetor also increases. The increased airflow creates a vacuum in the Venturi, and the main metering system begins to discharge fuel. On our graph, note that the main metering system provides an economical fuel-air mixture at cruising speeds. Here's how it works. As the engine approaches cruising speed, the increased airflow through the Venturi creates a vacuum or low-pressure area in the Venturi of the carburetor. Atmospheric pressure present in the bowl causes fuel to flow to the lower pressure area created by the Venturi and magnified by the booster Venturi. Looking at our graph, we see that for high-speed or full-load operation, the fuel-air mixture must be enriched to gain increased engine power. In the BBD, power enrichment is accomplished by two calibrated metering rods connected to a vacuum-actuated step-up piston. This piston rides on a spring which keeps the piston at the top of its cylinder during low vacuum. This lifts the metering rods so the smallest part of the taper extends into the main metering jets, which allows maximum fuel flow into the main well for power enrichment. At idle, part throttle, or cruise, high vacuum causes the piston to compress the spring, moving the metering rods deeper into the main metering jets. This restricts fuel flow to the main well. Mechanical control of the metering rod is also accomplished by the rod lifter on the accelerator pump rod. To this point, we've looked at two of the three fuel metering systems in the BBD 2 Venturi carburetor. Now let's get into pump circuit operation. When the throttle valves are opened suddenly to accelerate from low speeds, airflow through the carburetor is increased immediately. However, there is a brief time lag before the fuel can begin to flow, overcoming its own inertia. This momentary lag leans out the fuel-air mixture. The piston-type accelerating pump mechanically supplies the fuel necessary to overcome this momentary lag. Fuel enters the pump cylinder through an inlet check valve in the bottom of the pump well below the pump piston. As the throttle lever is moved, the pump link and drive spring push the pump piston down. Fuel is forced through a passage around the pump discharge check ball and out the pump discharge jets in the Venturi cluster. In summary, the basic circuits in the BBD 2 Venturi carburetor operate similarly as other carburetors. The float supplies fuel to the metering systems. The idle circuit provides the fuel mixture for idle and low-speed performance. The main metering and power enrichment circuits provide an economical fuel mixture at cruising or higher speeds. The accelerator pump circuit makes extra fuel available during acceleration, and the choke helps cold starting through engine warm-up. In this portion of the film, we'll look into several drivability symptoms and relate them to the service adjustment procedure. But remember, the carburetor is not always at fault. Be sure to use your technical service manual and film reference book to identify other possible service needs. Starting with the float, drivability symptoms requiring service are flooding and low and high speed surge. Actually, any drive symptom that happens at idle, low speed, and cruise usually relates to the float. Also, loss of power during sustained high-speed acceleration or sustained full throttle operation could be caused by fuel starvation. Here's how to correct these conditions. First, loosen the 6 screws holding the air horn. Then remove these screws and disconnect the choke vacuum diaphragm hose. Next, carefully remove the 2 choke link clips and accelerator pump link clip. The air horn may now be removed. To measure the float level, place a straight edge across the top of the float bowl. Hold the float up and measure to the top of the float. If adjustment is needed, simply bend the float lip. Then measure the float level again. Use caution when making this adjustment because the soft needle tip can be damaged by too much pressure. Float height specifications are in the technical service manual. The main metering circuit provides the right fuel-air mixture during cruise and power enrichment. If a cruise surge occurs between 45 to about 60 miles per hour, or if there seems to be a lack of passing power, the main metering rods may require adjustment. With air horn in place, remove the dust cover and the rod lifter lock screw. Then lift the vacuum piston and metering rod assembly out of the air horn. Measure the gap between the step-up piston and the metering rod assembly. Your technical service manual has the specifications. To adjust the gap, turn the adjusting screw. A counterclockwise turn leans the fuel mixture, and a clockwise turn gives a rich mixture. Before installing the assembly in the air horn, make sure that the spring maintains pressure against both metering rods. If the rods flutter, it could cause an erratic high-speed surge. When installing the vacuum piston and metering rod assembly, carefully insert the metering rods through the access holes and into the main metering jets. Then install the rod lifter lock screw. Next, we'll adjust the vacuum piston, which completes our main metering service procedure. First, close the throttle valves by backing off the curb idle screw. Be sure to count the turns. We must return this screw to its original position later. Now turn the idle screw in 1 full turn. Hold moderate pressure on the rod lifter tab and fully depress the vacuum piston. Then tighten the rod lifter lock screw. It's also necessary to adjust the accelerator pump before returning the curb idle screw to its original setting. So let's take a look at the accelerator pump and some related drivability symptoms too. Accelerator pump service may be in order if the engine stalls when it's hot or cold, or if it hesitates accelerating at low speeds. A good tip to remember is that if the engine coughs through the carburetor and the air horn appears sooty, the mixture is too lean. An over-rich mixture could cause the engine to lag or hesitate, but it won't cough. To adjust the accelerator pump, First, close the throttle valve using the curb idle screw. Then open the choke valve so that the fast idle cam allows the throttle valves to fully seat in the bores. Turn the curb idle adjusting screw clockwise until it makes contact with the stop. Make 2 more complete turns. Use a T-scale to measure the distance between the air horn lip and the top of the accelerator pump shaft. Your technical service manual contains the clearance specification. To adjust accelerator pump shaft height, loosen the pump arm lock screw and adjust pump travel to proper specifications. Then tighten the pump arm lock screw and install the dust cover. The choke is next in line for service adjustment. Some typical drivability symptoms related to the choke are no or hard starts, rough idle when the engine is cold, poor low-speed performance or stalling with a cold engine, or the engine coughs. Some more choke symptoms are too fast or too slow an idle with a cold engine, or the fast idle lasts too long. Then there's stalling when the engine's warm, not hot. To service the choke, make adjustments in this order. Call it 5 service steps to a happy choke. First, adjust the initial choke clearance. Second, adjust the fast idle linkage. Third, adjust the choke unloader. Step 4 is the choke cover, and Step 5 is adjusting fast idle RPM. Starting with Step 1, adjust initial choke clearance by turning the choke cover 1/4 turn clockwise. This applies tension against the choke cover spring. Then apply about 19 inches of vacuum to the diaphragm. Open the throttle valve slightly to place the fast idle screw on the high step of the cam. Now measure the clearance between the top edge of the choke and the air horn wall. Bend the connector link from the diaphragm at the U to obtain the specified dimension. Step 2. Set up the fast idle linkage. Place the fast idle set screw on the second step of the cam and against the high step shoulder. Make sure the choke cover is still set at 1/4 turn clockwise from Step 1. Measure the clearance between the top edge of the choke and the air horn wall and compare it with specifications. If necessary, bend the fast idle cam connector rod to adjust the clearance to specification. Step 3. The choke unloader setting is made with the carburetor at wide open throttle and the choke valve closed as far as possible without forcing it. Notice that the unloader tang pushes against the fast idle cam to open the choke part way to clear a flooded carburetor. If clearance is not as specified, bend the tang to adjust it to specifications. This adjustment should be rechecked on the car to be certain the linkage is permitting full throttle movement. Also check that the tang is not binding on the fast idle cam. Step 4 is the automatic choke cover. The service adjustment is easy. For longer choke operation, simply loosen the housing retaining screws and rotate the cover clockwise. For a shorter operation time, turn the cover counterclockwise, set within the OK range as shown in the TSM. The drivability symptoms mentioned earlier, such as fast idle too long or the engine stalls after a short warm-up, but not when hot, can usually be corrected by adjusting the automatic choke cover. Step 5. Adjustment to fast idle speed is performed after the engine reaches operating temperature. With EGR and TCS disconnected, here's how. This is the idle adjustment screw location. The fast idle screw is the inboard set screw, and the idle stop screw is the outboard screw. Set the fast idle screw on the second step of the fast idle cam. Refer to your technical service manual and adjust the fast idle screw to the settings specified for the particular model vehicle. Here we see some typical symptoms that may occur at idle or low operating speeds. Note that these symptoms relate to a hot engine. If the condition is a hot engine that stalls, the curb idle screw may require adjustment. If equipped with an idle speed solenoid, turn the nut on the solenoid plunger in or out to obtain the specified idle RPM. Adjusting the idle can also involve resetting the idle mixture. Also, if the engine idles rough when it's hot, the idle mixture screws may need some adjustment. Be sure to remember that idle settings are critical on emission-controlled engines. When performing this service, always refer to the Technical Service Manual for step-by-step engine idle speed and mixture setting procedures. These adjustments are made with air cleaner in place and the engine at operating temperature. These are the idle mixture adjusting screws. Plastic limiter caps installed over the idle mixture screws limit the adjustment range and control exhaust emission levels at idle speeds. If the car does not have a catalytic converter, an infrared analyzer test probe may be inserted in the exhaust pipe. Idle mixture screws with the plastic idle limiter caps in place are adjusted to obtain proper idle speed at the specified carbon monoxide level. On cars with a catalytic converter, the tachometer method must be used. However, the plastic idle limiter caps must be removed to adjust to a lean drop idle setting. This procedure is detailed in the Technical Service Manual. The idle limiter caps may be removed by using a soldering gun to melt through the plastic, or drive a number 10 sheet metal screw into the center of the cap and turn it clockwise. Start the engine and let it warm up to operating temperature. Then adjust the idle speed to the RPM specified in your Technical Service Manual. Essentially, the procedure is to adjust each mixture screw to obtain the highest RPM, moving each mixture screw equal amounts, unless the engine demands otherwise. If the RPM increases above specifications, reset the curb idle screw. Once the best idle is achieved, turn the idle mixture screws clockwise to lean the mixture until the specified drop in RPM is obtained. Install new plastic idle limiter caps over the idle mixture screws. Service caps are blue in color. Make sure that the limiter cap tab rests against the full rich stop. Take care not to disturb the idle mixture setting while installing the caps. Another symptom that affects performance in the idle low-speed circuit is a low-speed surge while the engine is hot. To correct the low-speed surge, look for dirt or an obstruction in the low-speed jet, low-speed well, the idle air bleed, idle channel, or idle port. Clean these passages as necessary. Remember, for carburetor diagnosis, an easy way to identify circuits requiring service is to relate the symptom and, when it happens, to this engine operating graph. The float affects the idle, main metering, and power circuits. Choke action affects fuel-air mixture from the time a cold engine is started until it reaches operating temperature. The idle and low-speed circuit involves fuel mixture and idle setting for lower engine speeds. For steady speed driving, around 45 miles per hour or more, look to the main metering circuit. This involves the vacuum piston and metering rod assembly. During high-speed or full load operation, the metering rods are also directly involved. Remember? The rods taper at the end to control fuel flow. And when the throttle is suddenly opened, the pump overcomes engine lag. When diagnosing engine performance and carburetor operation, always consider all the possibilities. Some of the drivability symptoms presented in this film can involve the entire fuel system, ignition system, emission devices, or the condition of the engine. The BBD 2 Venturi carburetor for AMC and Jeep 6-cylinder engines is designed to provide proper engine performance. You must provide proper service to keep engine performance where it should be. Service is your business. Be sure to use your film reference book to help you do your job the right way, quickly and professionally, because you must be the expert under the hood.